Bonjour, good day, and welcome to this presentation called Using the Power of LSP to Create Unconventional Language Client-Server Integrations. But let me first introduce myself and the co-presenter. My name is Marc Dumais. I am an Eclipse Theia committer and co-lead. Previously, I was a committer for the Eclipse CDT project, improving debugging. I am a software developer working at Ericsson for 21 years, the team lead of the internal Theia framework team there. And my colleague is Vincent Fognito. He is a Eclipse Theia committer since mid-2018. He is a software developer at Ericsson for 5 years, 3 as a student and 2 since graduating. And I wanted to mention that he is one of the most prolific committers on the project since he joined it. He has numerous commits. So here is the agenda for the presentation. We start with an introduction, then just give you the minimum about Language Server Protocol, LSP. Then we move on to the meat of the presentation where we talk about integrating tools other than compilers and linters using LSP. And finally, my colleague Vincent will show you a demo of one such integration that we prototyped that aims to detect cryptography usage in code and comments in a Theia or VS Code workspace. So, where did we get this idea to experiment with LSP to integrate in Theia and VS Code tools other than compilers and linters? Well, a couple of years ago, a colleague of ours with an awesome British accent, hi David, heard about our work on the Theia project before even it was named Eclipse Theia, I think. He was particularly interested in the LSP and the potential to use it to add intelligence in the IDE to help our developers. So to help them take the right decisions in some common but often misunderstood tasks. For example, picking an open source library to do X while making sure that it's license compatible with the project and responds to certain criteria that is imposed on that project. He then laid out about a dozen such integrations that could potentially be valuable. At the time, Theia was not what it is today, and our priorities were elsewhere. But earlier this year, we came back to this and decided to prototype one of these ideas. So, though nothing necessarily revolutionary was created, we wanted to share the result with you in the hope that it may inspire some people to try new things with LSP and eventually maybe put something out there that might be useful and enhance the ecosystem. So, what is the Language Server Protocol? The LSP defines how development tools, IDEs, editors can communicate in a standardized way with so-called language servers that hold the intelligence about a language. The LSP is flexible. You can extend it to do things that it does not do to begin with. It's available already in many editors and IDEs that have an LSP client. Why use LSP? Well, we certainly could integrate a given CLI tool from scratch without using LSP. So why not do that? Why use LSP in general? The main advantage that LSP brings is not necessarily related to enhanced language capabilities in the IDE. Features like code completion, quick help on hover, code formatting, refactorings, and so on already existed before LSP. So what's the main advantage then? In one word, reuse. Without LSP, each IDE or editor had to implement language intelligence for each language pretty much from scratch. For example, in Eclipse CDT, the C++ parser and indexer component is implemented in Java, like the rest of CDT, and would not be easily reusable in other IDEs or editors. In contrast, with LSP, any editor or IDE that has a language client can potentially reuse an existing language server, only investing a tiny effort compared to coding equivalent from scratch. For C++, a good language server exists named ClangD. ClangD is developed by the same team, LLVM, that produces the Clang compiler. As the name suggests, they are related. ClangD shares some of the code base of Clang and thus benefits from its C++ parser and other goodies, giving it high accuracy. ClangD is already integrated in the form of a VS Code extension called VS Code-ClangD. By using that extension, it's possible to add C++ intelligence in Theia apps and VS Code using ClangD under the hood. It's even conceivable that ClangD could be retrofitted in CDT eventually as LSP support in the classic Eclipse platform progresses. By factoring out the language intelligence to a language server running in an external process, clients can be simpler, just worrying about how to best show that information. This opens the door to the creation of one or a couple of very good language server for each language or purpose versus one per IDE editor now for the larger ecosystem's benefit. To keep things simple for this presentation and the prototype that we did, we used a single feature from LSP called Diagnostics. So in the language server protocol, Diagnostics let the language server report such things as errors and warnings emitted by compiler, linters, and other tools. They will usually be about a specific file and location in that file. So it could be a line and a column. Sometimes it can be a range. On the client side, diagnostics can be handled as seen fit. In Theia apps and in VS Code, they are called errors and problem markers respectively and listed in a dedicated view. They are also represented visually in open editors when their location is exposed with a squiggly red line for errors, a yellow line for warnings. Hovering over these will give you the text of the marker. When a diagnostic has a location, one can double-click on a marker in the dedicated view to be taken to where it applies in an editor, opening the editor and revealing that location if it's not already the case. The other LSP concept I'll introduce is incremental text document synchronization. This is an optimization that can significantly reduce the data transfers between language client and server. It's used in the prototype demo shortly, so let's introduce it. In most integration, the language client will keep the language server aware of changes in an editor. This can happen even if the editor's content has not yet been saved to disk. The baseline way to do this is for the client to send to the server the old content of the editor whenever there's a change. With big files and frequent saves, this can waste a lot of resources and be detrimental to user experience. Essentially, when using incremental text document synchronization, the language client sends to the language server only a diff of what changed instead of the old file whenever there's a change. You know what else is great? Assuming you're using the Microsoft language client in a Theia app or in VS Code, all that's required is to install these three notification handlers in your language server and declare that capability at initialization. Your client will do the rest, sending corresponding notifications at appropriate times as follows. Number one, when a file is opened that a given client cares about, the client sends did open text document notification. It can contain the content of the whole editor, or it can let the language server read it from disk itself. Either way, the server should analyze the file, the content of the editor, and send a set of diagnostics for any problem found. Number two, when a file opened in an editor is modified, the client sends the did change text document notification. It contains an abbreviated form of what changed rather than the full content of the editor. The language server should then reanalyze the new version of the editor's content and emit a new set of diagnostics. Note that the updated editor's content does not even need to be saved to this for this to work. And number three, when an editor is closed, the client sends to the server the did close text document notification, and the language server can pretty much stop caring about that file. So we've barely scratched the surface about language server protocol here. If you'd like to learn more, here's a good presentation from a past EclipseCon that could be a good way to start. LSP, looking beyond compilers and linters. This is the final section before the demo. Now that we know enough about LSP to survive, let's go back to integrating tools other than compilers and linters and see how it all comes together nicely. Given that there exists a CLI tool that can provide useful information about a developer's workspace content, it can be relatively low-hanging fruit to integrate that tool using LSP in the form of a VS Code extension that can be used as well in Theia applications. On the client side, all the basics are covered by the Microsoft language client with little left to code. On the server side, a simple TypeScript server can be created that invokes the CLI tool on the content of open file editor, and again whenever it's changed, each time parsing the output of the tool and extracting problems and emitting a new set of diagnostic for them. The diagnostics are then shown in the IDE, in a dedicated view, and in the editor where the user is typing itself. So long as it's relatively quick to run the CLI tool when a file changes, the diagnostics can alert the developer that what was just modified potentially created a new problem before they have the time to move on and forget about that line of code. So what kind of CLI tools that are not compilers and linters can we consider to integrate using LSP? Um, well, there's already pretty good help in most languages about making code compile and root out smells. But in the meantime, other important aspects are left mostly unaddressed at this point. Let's see a couple of examples where extra help would be beneficial. The first type of command line tool that we could consider to integrate is any that would help with managing our FOSS dependencies. From my own experience with the Eclipse Theia project, it would be awesome to be able to get help with discovering and validating for appropriateness the licenses of the numerous recursive runtime dependencies of the project. It would also be helpful if it could help us quickly make sense of the licensing implications of adding a given dependency to the project. The Dash Licenses tool, a new tool by the Eclipse Foundation, is an interesting candidate for integration. It currently supports projects in JavaScript, TypeScript, and Java, with dependencies respectively in the form of NPM packages and Maven packages, checking all project's dependencies against the IP databases of the foundation and a public service called clearly defined. When Dash licenses cannot establish with confidence that a dependency has a proper license, more scrutiny is required. In an eventual integration, we could, for example, at workspace startup, perform a baseline scan of the workspace, then watch for any dependency change and rerun Dash licenses, if possible, only on a subset of the project's dependencies affected by the change. Any issue with the dependency of a dependency or any level of depth in the tree could be reported on the dependency that we actually add to our project, because this is where we have control. Yeah, another category where we could really use any possible help is managing security vulnerability in our dependencies. So as security becomes an increasingly important matter, it would facilitate the exposure of a project's usage of FOSS dependencies that have known vulnerabilities if this fact was highlighted in the developer's IDE. Then probably some mechanism to permit keeping track of discovered vulnerabilities and permit some to be classified as can be safely ignored, so that if found in the future, it could be ignored, could be some helpful feature of such an integration. So here we have the final category that we want to present of potential targets for integration in LSP. So this is related to export restrictions regarding cryptography and the need to manage cryptography usage in code base in many companies and organizations. So you'll probably be aware that for legal reasons, encryption usage in software that is being exported is quite strictly controlled and needs to be managed by the organization that produce such software. So the first step in any problem is to be aware, and for that, there exists a command line tool, an open source one called crypto-detector by Wind River, hosted on GitHub, that can help. It's licensed under Apache 2, and it uses a mix of heuristics and more specific scans to detect specific cryptographic usage and also some generic language that could hint to cryptography being used. It is configurable, so depending on what you're looking for, you can configure to zero in on some things more than others. And this is the example, the tool that we picked for prototyping that my colleague Vince will be demoing shortly.
Thank you, Mark. We will now look at the extension in more detail and also see it in action. The two main use cases we have for the extension is that it should report diagnostics directly in the editor, and we should also have immediate feedback for developers and also work with unsafe document changes. We will now take a look at the crypto-detector extension in more detail and understand its implementation. The extension is composed of two parts, the client and the server. In the client's implementation, we can see that it has two methods, the activate and deactivate. In the activate method, we are able to set some server options as well as some language client options. In the language client options, we can set some document selectors such as JavaScript, TypeScript, C, and C++, which are the languages or file types that the server is interested in. We can also set the diagnostic collection name so that we're able to group diagnostics from this server under a common name. We're also able to set an output channel name so that we can view messages from the client and server in the output channel. The interesting part of the extension is, of course, the server itself. We can see that we're listening to the uninitialized request where we set capabilities of this language server. We set that we want a text document sync as incremental. This means that when a document is first opened, it will send the entire document to be scanned, but any subsequent updates will only result in the incremental changes being sent. We're also interested in the following three events: the onDidOpen text document, the onDidChange text document, and the onDidClose text document. In the onDidOpen text document, when a document is first opened, the file will be scanned so that developers are able to view any problems in the file. The interesting event, however, is the onDidChange text document, which allows developers to get instant feedback based of cryptography detection as they type, and even works with unsafe buffers, meaning that the file does not need to be saved in the file system in order to produce any diagnostics. We also listen to the onDidClose text document, which simply clears the diagnostics for the closed file, similarly to how TypeScript handles the event. In both the onDidChange text document and the onDidClose text document, we spawned the Python 3 detector script in order to produce output. This script will look for any keywords of cryptography and any use or API use of cryptography libraries. We then parse this output and produce diagnostics which will be viewed in the editor. For each diagnostic, we will get its severity, its message for end users, and also its range, so its location in the document. This is the main purpose of the extension, but now we will see it in action. We will now take a look at the crypto-detector extension in action. Currently, I have a workspace open where there is already present some cryptography. As you can see in the problems view, there are no problems at the moment since there are no open editors. When I open the crypto.js editor, because of the onDidOpen text document event, we are able to scan the document and test if there are any cryptography present. As you can see, the scan resulted in some API and library detection of cryptography, which is the secondary and more in-depth scan that the tool provides. If I were to perform some simple cryptography such as a keyword, you can see that it creates a warning instead of an error severity, and it has a more generic name. You can also see that as I was typing, this diagnostic was created. So this is the onDidUpdate text document event. You can also see that the document is still unsaved, so it's not on my file system. This was one of the requirements of the extension. We wanted to provide some immediate feedback without the need for the document to be saved on the file system. If I were to remove this line of code, you can see that the diagnostic is also removed. Going to any one of these diagnostics would move to the file or to the marker in the editor, so it would provide developers easy access to their use of cryptography. If the document is closed, then the collection of diagnostics for that document is cleared from the view. These were the three events that we had previously talked about. The ondid open text document should scan the document and provide diagnostics for it. The ondid update text document should provide the editor with diagnostics as the user's type, as well as being able to work with unsafe buffers. The ondid close text document event would clear the diagnostics from the view. Potential improvements for the extension can include better configuration of the diagnostics, the ability to control the severity of the diagnostics. So if we're interested in more severe diagnostics only, we can potentially hide warnings or make some diagnostics such as algorithms more severe than stuff like library use of cryptography. We can also provide tasks which would scan the entire workspace for cryptography instead of only open editors. And we can also do something like ESLint, where we're able to disable some diagnostics as false positives in the code directly. This is useful as if we were to disable use of cryptography in the file as false positives, then this would also be potentially added into the source control where other developers can benefit from it. This is the extension in depth, and I hope you enjoyed.
Hello, Mark here. So we have a question. Does LSP have capabilities for refactoring? I believe so. It is a more advanced feature though. And I don't think we have it right now, at least not in our prototype. Are there any limitations of LSP-based editors in comparison with desktop IDs? Good question. As far as I know, the features that can be offered using LSP are pretty much the same as were there before. On the top of my head, it is maybe a different way to implement it. Less people will need to implement intelligence in an IDE reusing existing language servers. But on the top of my head, I do not see something we could not do with LSP that we could do with, but I'm not an expert. Okay, another question. Did you already discuss the integration with Dash licenses? No, we did this prototype earlier in the year before Dash licenses was available. Else, it's possible we might have picked Dash licenses. But yeah, it's only for now. It's only a nice to have, something we would like to have, but no work has been done on this integration. Is there multi-user support? The question might be asking about something a bit like Google Docs to be able to co-edit at the same time. We do not have this feature as of yet in Theia, if it's what was meant. And I think it is a bit orthogonal to LSP. I think it could be done with or without. Another question, did you generate an LSP for C, TypeScript, and CPP and combine them somehow? Or did you write your own LSP? So this demo, the crypto language server was working alongside with other language servers that did provide the TypeScript and possibly other languages feedback about these other things. Language server can work in parallel. So something like cryptography, it could be valuable to run it alongside other language servers, since it can find even mention in comments, at least for that part. Okay, another question. Did you see the previous talk from Lars Geyer? Sorry, I don't want to massacre the name too much, about automated open source compliance toolchain. There could be some interesting connection points. Yes, I have not seen this presentation, but I have a big backlog when the videos are up, so I will add this to the backlog. Thank you. Any other questions? That seems to be the end for now. Oh, another one. Why hasn't static code analysis tool picked up this way of integrating their own yet, but typically still provide n different integration per IDE instead? Well, for some languages, it has already happened. So TypeScript might be a bit in advance for that compared to others because it's newer and it is done by Microsoft that also do VS Code. But in TypeScript, we have that. I believe that the ESLint, or was it TSLint? One of the two anyway is integrated as a plugin to the language server. And I believe there are other examples where we have something like that already. But of course, there are linters still that are standalone and not integrated using LSP, and it might be a good idea to have at least some type of integration using LSP instead of doing everything from scratch. Good thought. Okay, another question. Is the server local or remote on a different machine? Is a remote server shared? Is a remote shared server a model LSP support? Well, now. Okay, so in this case, the server is local, but it could be remote. I think the only concern is that you need to start it somehow, or at least locally, that's what we do. We start it when we need it. But it could be possible that the language server could be a microservice or something, kind of a pool that you take the next available one. I think the only restriction is that the language server needs to have access to the same file system as your editor. So if it's on a network, it should mount your home or something and be able to agree with the client that what the path is for a given file. And the language server needs to access the same files as the client. So there's this limitation, but other than that, it is possible to run it remotely in general. Okay. No further questions. All right. So thanks everyone for joining us and having all these interesting questions. Goodbye.